Hey everybody, welcome back. A couple more sections of circles. We learned last time about what's a central angle, which starts in the center of a circle and it heads out to the circle itself. And you have some degree measure here. And, for instance, that's 60 degrees as an angle. Then the arc angle out here will also be 60 degrees. So the central angle and the arc angle will always have the same value. Well, today we're going to learn a new kind of angle. And this one's called an inscribed angle. It's inscribed means it's inside the circle, and the angle will actually start on the inside of the circle. So they have a picture here for you right below. It says inscribed angle. See that those blue lines create an angle from inside the circle? And then the secants, the two lines are secants, they run out, as you see they're heading out to the right here. They intercept the circle later on. So you still have an arc angle here, and it calls intercepted arc. And that angle measure and the inscribed angle measure have a relationship we'll talk about in a moment. But I just want to get the terminology with you. So again, you have your inscribed angle. Let me get rid of some of this mess here. You have your inscribed angle. Hang on. You have your inscribed angle here, which is this part. It touches the circle. And then your arc angle is out here. So, when we have these angles, so I'll draw one over here. Here's my inscribed angle. And if this is 40 degrees in here, at the angle itself that's inscribed, when you get out to the arc, it's not going to be 40 degrees, but it is a number that's easy to calculate. It's going to be double the inscribed angle. It'll be 80 degrees. And we'll see plenty of examples coming up showing you why and how that works out. It may be hard to understand at this point, but the examples will help illustrate why they are the values that they are, okay? Okay, and likewise, if you are given an arc angle out here that's 80 degrees, you can then calculate the inscribed angle to be half of that. So the relationship is 2 to 1 or 1 to 2, depending on which one you get. So let's try some of these as examples. Down here, example 1. You look at the 50 degrees they've got right here. Oops, I'm going to go to the highlighter. This right here is 50 degrees. That's inscribed. Well, it heads out to this arc angle. And that arc angle will be double what the inscribed angle is. So that will be 100 degrees on the arc. Remember, a full circle is 360, right? So that's 100 of that full 360. Now, let's see what else we got. They have over here on the right, they have, if I can zoom in for you, on the right side they've got this 48 degrees. That's an arc angle. Well, I can follow it into an inscribed angle way in there, and that would be, let me see, clear that out of there first for you. That's going to be half of the 48, so it's going to be 24 degrees. So this is 24 degrees in here as an inscribed angle. And now you have to start looking around, finding other items that will help you. So let me show you something that stands out as I see a diameter. It's half a circle. And any diameter, hopefully you know now, is half a circle is 180 degrees. Well, I've got already the 100 over here on the left. Well, how much do I have over here then? If I used up 100 on the left, I would have 80 out here as an arc angle. Okay, whoops, that's not what we wanted. Okay, what else can we do? Well, down below on the other side also. This is also 180 over here because of this half circle. Well, I used up 48 over here. So 180 minus 48, again, I'll do some math over here. 180 minus 48 gives me, 132? Yeah. So what's left here is 132 degrees. And if you look carefully, you have all four values here on the outside. 132, the 48, the 80. Those all add up to 360. And then you have also all the internal angles. Now you can go answer the questions over here. And then you say, what's the measure of angle T? Well, T's over here on the left, and we found it to be 24 degrees. So that was pretty easy. Again, finding the work first is better than trying to find the answer. They want an arc. Again, they have the arc here. Arc angle QR. Well, that's on the upper right hand. That's the 80 degrees here. And that's what I need to do. So the main idea in this whole chapter, or this whole section, is that the inscribed angle is half of the arc angle. or the arc angle is double the inscribed angle. All right, here's an interesting little problem. A lot of lines going on, but the key on this, well, this says, let's look at the picture before we find any values. This 31 degrees is this inscribed angle. Well, out here is a arc angle, correct? Well, it would be double, so it's going to be 62 degrees out here. Well, what's interesting about this is this inscribed angle over here opens to the exact same 62 degrees. So I can bring that 62 down to where this letter T is, cut it in half, and I'll have 31 degrees, just like the one down here. So when two angles open to the same arc, they're going to have the same value. And angle T and angle U open to the same 62, so they're both 31 degrees. And at this point, I'm just going to start giving you some examples and help you out here. It says find the measure of the red arc. Of the red arc or the angle. Okay, well, in this case, they want this angle in here, and they gave me the 90 out here in the arc, so I got to translate that down there. And the hard part is always remember, is it double or half? And the inscribed angles will be half, so this is going to be 45 degrees in here. On number 2, the 38 is now the inscribed angle. So now I have to go out to the arc. And double that to be, I guess, 76 degrees. And here's one of these other examples I just gave you a moment ago. They want you to find x. X opens up. Is this a W over here? It looks like a W. So x opens up to ZW. Well, guess what? So does the letter Y, the Y angle. So this 72 translates out here to be 144 degrees. And likewise, it goes back into the x as 72 degrees. Because both x and y open to the same arc angle. All right, let's go find some other examples for you, and then you'll have some homework. Again, just this, we're not going to spend time on this, but you can put different shapes inside of circles. And what's kind of nice about a square or a four-sided figure, hopefully remember that four-sided figure is 360 degrees. Well, a circle is 360, right? So all four of these angles, inside, if it's a four-sided figure, would add to 360. So it's there's some neat things we can do with that, but time will not allow. So I'll do some more examples here for you, and then I'll let you folks do the rest for homework. I'll try to give you another taste here. Again, they say find the indicated measure. They want the measure of angle A. So be careful what they're looking for. Like they're looking for angles. This would be this one in here, right? Sometimes they want you to find an arc, RS. They want you to find this. So just make sure you know what you're trying to find. And don't always go right to what you're trying to find. I always suggest filling in all the things you can find on the picture first, then go look for the answer. A little easier that way. All right, so they want A. It's 84 out here as a arc. I'll translate down. You just cut it in half. So that'd be 42. Let's see. Number 4 here, find angle G. Well, that's angle G, by the way, is going to be way out here. That's from here to here. This arc, or this value here. I have neither one of those, so I have to do a little work. Well, I know that the full circle is going to be 360. From here to here is 360, and I know that I have 70 and 120 so far. If I subtract those from the 360, I would be finding this arc angle out here. And then I can cut that in half to find angle G. So those are my steps that I'm going to do here. So I'm going to add up those two numbers, 70 and 120. I get 190. That's 190 for this, okay? And then I subtract 360 minus 190, and I get 170. So this is 170 out here, 170 as an arc angle. Well, I didn't find my answer yet. I got to find angle G in here. So I got to translate that down, cut it in half. 1/2 of 170 is going to be 85 degrees for angle G. Here's another good example where you see these diameters. Okay, it's a chord going right through the center. You got 180 here, you got 180 here, okay? And then you can use those numbers to find some other values. So always keep that in mind when you see a diameter. Start getting in your mind what values come up. So we do have that there. So we have the diameter, and 180, and they want me to find angle N way over here. Well, okay, that's an inscribed angle. So I'm going to look across to the arc. Well, I don't have it out here either. I don't have that either. But I do have the 160, which comes part of this 180 over here in this half of a circle. All right, so let me clean my mess up here and do some math for you. So we got the 180 out here and the 60 there. So it's 180 minus that 160 gives me 20. So it's 20 degrees right in here at the arc. Well, I can translate that down, cut it in half. This angle N will be 10 degrees right in here. So that's how you find that. So again, you just have to go finding pieces that you know. You know circle's 360, a half's 180, and apply that with what's given to you, and you'll find other pieces. Find all the pieces, then you'll be able to eventually find what you're working on. RS is out here. That's an arc. They give you the central angle. This is pretty easy. Take it out there and double it up. So it's 120, 134. Okay. All right, there'll be some homework assigned to you. All right, folks, good luck.